Good morning everyone, my name is Vincent Ridgard, Process Engineer at Multotec Solid Liquid Separation Division, and I head up the environmental sector there. So before we get started today, I think it is important just to do a proper differentiation between total suspended solids, which is the fines that we've mostly been dealing with up to now, which is defined as solids in suspension. These are solids that are not dissolved. These solids are physically visible. These particles vary in size and are also related to the turbidity that you find within a typical water stream. On the other side of it, you also get total dissolved solids. So these dissolved cations and anions, which you often find in your process water stream, is as a result of many factors, one of it being the exposed rock face of these very fine solids, which allow for natural leaching of contaminants and metals, residual metals, to leach into your water stream and can act as a contaminant in your process water and also make your discharge water non-compliant. So to treat this water, there are multiple options to consider. There's obviously also different types of waters: your groundwater, water treatment plant effluent, which is your tailings water, which we will be dealing with mostly today, and obviously surface waters such as old historic pits. To treat these, you've got different technologies to your disposal. These comprise of membrane technologies and chemical precipitation plants, which are your more conventional systems. But today we will focus on a very niche technology, which is continuous countercurrent ion exchange, to remove contaminants, to scavenge for contaminants, and also residual precious metals. So if you consider a generic mine site, as you can see, there are various areas that you can consider for water treatment as well as precious metals scavenging. These areas include the run of mine water, your stormwater dams, your pollution control dams, as well as your return water dams. But of course, the area we will be focusing on the most today is the tailings dam. So as I mentioned, we will be focusing more on the niche technologies rather than the conventional to scavenge these contaminants and precious metals from our tailings water streams. And to start off, we need to consider what is resin chemistry. So a resin bead is an insoluble polymeric substance which contains these loosely held ions which are exchangeable with others in a solution. So when the resin is exposed to a stream that has a contaminant in, such as calcium in this instance, which can cause increased reagent consumption in your plant, the calcium is exchanged for H+ ions, and then when you regenerate your resin with sulfuric acid, in this case, then your resin is regenerated and ready to be reused again. Resin chemistry has always been well understood and respected. The problem was always that there was no technology to facilitate the extreme advantages that the chemistry can provide. Multotec, together with partners Cleantech, supply a continuous countercurrent ion exchange system to the mining sector, and the system works as follows. Alright, so considering the technology, this is our deselect system. Cation removal and anion removal sections consisting of an adsorption, desorption and a wash column. The feed water, contaminated feed water, enters the bottom of the column and simultaneously removes TDS and TSS, while your fresh resin is added at the top countercurrently, and your clean product water then exits the top of the column. Considering the resin chemistry happening on the inside, as we just saw now, calcium is exchanged for the loosely held functional group H+, and your resin is then periodically removed from the bottom of your column via pneumatic airlifts. It goes over a dewatering screen into your desorption column, where sulfuric acid is then added to regenerate your resin. This is done at very high concentrations, and as you can see, calcium is then removed from the resin bead, H+ is regenerated, and calcium sulfate is created as a byproduct, which is gypsum, which is obviously a valuable byproduct. The resin is then sent to a wash column just to wash off any residual acid, before being sent back to the top of the adsorption column via pneumatic airlifts to complete your cycle. So in the case of TDS, the hyena's definition can in actual fact be twofold. The first section that we need to consider are the contaminants, which actually also scavenge valuable precious metals, your target elements, as well as reagents from your process stream. The second one is then of course the scavenging technologies, which we referred to originally, which can recover precious metals which would have otherwise been lost to the environment. So considering the first one, we always need to consider the balance between the cost of your investment, the recovery of your product, and reagent consumption. And to illustrate this, I have put together a case study. In a gold processing plant, water is used extensively. The reuse of water is obviously encouraged for two reasons. Firstly, to conserve water, and secondly, to minimize discharge of contaminated wastewater. The problem is when you start recycling process water, you build up contaminants, and contaminants in your process water can reduce recovery. So the Department of Mining Engineering at Urmia University in Iran did an investigation into the reuse of process water in the gold cyanidation process. What they did was they tested 4 different waters, first one being the original process water, the second process water that's been treated for 30 minutes using some sort of adsorbent, third water, same process but just for a longer duration of 1 hour of treatment, and then the fourth process water was just to neutralize any cyanide in the process. You can see here the various contaminants, concentrations, mercury quite high in the original process water, slowly decreasing with the treatment, and you're also losing some gold as you treat it. These are just some representative elements, but of course there could also be copper and iron, etc. So when they did the investigation, the results showed that using fresh water in the plant increased the recovery of gold to 93% from the original 84% using the original process water. The advantages of some form of treatment, process water 2 and process water 3, is also evident, obtaining 88 or 89 and 91% recoveries. Silver recovery also increased to about 72% from 60%. There is, however, a flip side to this. When you use completely fresh water from the river, you can see that your cyanide concentration in your water is 0, and your total cyanide that you need to add is significantly higher than what it is in your process water streams that are being recycled back from your tailings. Considering another case study at another client, also a gold application, you can see there that FTSF water caused excessively high lime consumption because of contaminants in that water, and CTSF and river water showed similar consumptions of lime. However, the highest gold recovery was achieved with river water. These higher recoveries in both the case studies can be attributed to the reduced contaminants that is present in the process water. While gangue minerals are insoluble in cyanide solution, some metallic minerals such as iron, copper, etc. are soluble and deprive the solution of its oxygen and cyanide, consequently reducing gold recovery. Moving on to the second definition of the hyena topic, we will now look at scavenging technologies to recover precious metals. And by utilizing our continuous countercurrent ion exchange system, you can see that we can recover all of these valuable precious metals, residual precious metals which would have otherwise been lost to the environment. An example of this is at a zinc mine where a water treatment plant was required on the tailings end of the plant. The water treatment required precipitation, conventional precipitation HDA system, as well as the desal X we looked at earlier, to ensure that the water is treated to a standard that will remove contaminants as the water is recycled back to the plant. However, when considering this water, we realized that there was also a significant amount of residual zinc which was slipping through the process. As such, we suggested adding a CLX column to recover this residual zinc from this process water prior to water treatment. As can be seen here by the process performance, zinc came in at a concentration of about 1,200 milligrams per liter, and after it was processed by the ion exchange plant, this product was upgraded to a zinc sulfate product of 10.5%. Another example of this is copper recovery process, where a feed grade of 68 milligrams per liter was fed to the ion exchange plant. More than 98% of this copper was recovered, and it was upgraded to a crystallization feed of 80 grams per liter. This process, as per the animation, consists of the following process streams. Tailings water is fed to the copper adsorption column, and the copper is absorbed onto the resin, where the copper depleted solution is sent to a water treatment plant. The resin is then transferred via pneumatic airlifts to a resin wash, and then sent to a desorption column to elute the copper from the resin. The resin is then washed and recycled back to the copper adsorption column. Focusing a little bit more on the copper elution section, sulfuric acid is used to elute the copper, and you end up with a copper sulfate product. So considering the economic evaluation of such a process, we estimate that for a concentration exceeding 100 milligrams per liter and operating at 150 cubes an hour, a payback then less than 12 months is possible. We believe that the best way to approach these situations is to do test work. We've got the capabilities at our facilities to do laboratory scale test work for resin screening, IX kinetics, equilibrium isotherms, column loading and elution tests, as well as pilot testing. We've got a 1 cube an hour test rig, which is an exact replica of the desal X system. My name is Vincent Ridgard, and I thank you for your time. Please see my contact details on the screen and kindly advise if there are any queries. Thank you very much.